Rec-
All right, guys. So I know that this unit is kind of going fast and furious. We just got started yesterday with some vocabulary and hopefully worked your way through that. So as we use some of the terminology, it's not going to catch you off guard. Um, it's all pretty straightforward, but you really do need to know more or less what's earning you money and what's costing you money in this unit. It's all about financial literacy. So that's basically kind of like you would say, just literacy by itself is being able to read. Well, this is being able to read money, um, for lack of a better term. So Unit 9, we're going to kick off talking about different ways that you can earn money, um, and not in terms of a job. Obviously, we all know we can get a job and we can get paid and we can earn money that way. But we're going to be talking about money that potentially was simply deposited into a an account and how that earns money for you just by being deposited. Okay. So for today, we're going to be talking about simple interest. Okay. Simple interest. All right. So before we can really get into the real gist of the lesson for today, we have to be sure that we're very aware of um, part of the mathematics that we would have learned in sixth grade, and that is um, percentages. Okay. So percentages, as we all know, you can recognize because they have that along with a number. They are I guess, a part compared to 100. Okay. It's always out of 100. That's literally what the word means, percent. If you think about the per part, PER, for every, right? So PER for every, right? When we say something per something else, that's for every one of those, you get one of those. So like $1 per hour. So that's one per hour. And then for this, so that's for every, and then the cent, okay, is 100. Because if you think about different things that are have that word in them, we call a penny a cent, right? Because it is part of 100. It takes 100 pennies to make a dollar. That's why we call it a cent. It's also why we call it a century, right? Because it takes 100 years to make that block of time. So we have per hundred, right? That's what percent means for every hundred. So um, as we look at percentages, okay, we could say, example one, say we have 3%. That means that as a ratio, okay, so that is the percentage form. And then as a ratio, it is 3 per 100, right? So 3 for every 100 that you have. And the reason I'm going over this is because we're going to need a different form, right? You cannot mathematically use a percentage. Okay. You have to have some other form of it. Well, this is a percentage. Okay. But we can't mathematically do anything with that. We can't divide with that. We can't add that to something. We can't multiply with that. that is a representation. Okay, that's a description. It's something that we can all relate to, we're all familiar with. But in mathematical terms, we need to understand that it means something else, right? It means that it's 3 per 100, which this is just a fraction, right? And we can do math with fractions. And better yet, we could actually make that into a decimal. Okay, so 3 hundredths, right? That's 3 per 100. That's 3 hundredths. So our decimal equivalent is 0.003. And that's, again, very important because we have to have an alternate version. We can't use 3, the number here, as it stands with the percent sign. We have to use some other form of it to do the math. Okay, so you have to change that as you go. So as we go through this unit, you're going to see that we change those percentages into their equivalent form so that we can include them in the problem. You're going to recognize the percentage because, right, it's got the symbol with it, but we can't actually do the math with the 3 there itself. Okay, so that's just taking a percentage and then showing 3 different forms. Now, if we were in 6th grade, I would teach you a little trick to remember how to switch a percentage from a percentage to a decimal or a decimal into a percentage. And it's very simple, okay? Because it's 100, because everything is per 100, it makes the conversion really easy, okay? So converting a percent into a decimal or back, right? Okay. How do you do it? Well, real easy, guys. Percent into a decimal, you're going to move the decimal. Oops. 2 spaces left. Okay, because essentially what we're going to be doing is setting it up as its representation, because 3% is 3 per 100. It's 3 over 100. That technically is 3 divided by 100. So we're dividing everything, that number, by 100. Okay, well, when you divide something by 100, you simply move the decimal. It ends up causing a place value shift from what it was, 2 spaces left. And if you'll notice in your 3 here, the decimal was right here behind it. And as we converted it to its decimal form, right, to 3 hundredths, it would have moved 2 spaces. Okay, so 1 going around the 3, and then the second one here is where we gain that 0 in front of the 3. So it's just 2 spaces to the left. Okay, if you're going to go the other way, right? Decimal to percent. Okay, so given a decimal value, can you go back to a percentage? And the answer is yes, right? It's very easy. We're basically going to, again, move the decimal 2 spaces right. Okay, and so that's all you do, right? So if we were given this initial 3, okay, 3 hundredths, okay, how do I make that a percentage? Well, I simply move that decimal 2 spaces to the right. So 1, 2. Okay, so it would go right there behind the 3. So 3 hundredths is 3%. And that's how that works. Okay, so the easy way to remember this, right, is we talked about in the past Dr. Pepper. Okay, and if you remember Dr. Pepper, okay, there are 2 letters in that. There's Dr. and Pepper, and then we've got decimal to percent, right? So moving from the letter D to the letter P, right? We've got 2 letters and we're going to the right. So decimal to percent, you go to the right. If you're going from a percent to a decimal, right, that is from the letter P to the letter D, again, 2 spaces, and we're moving left. Okay, so real quick, easy way to remember how to go back and forth between decimal and percentage. Okay, and that's important because you might be at times asked, okay, something along the lines of, so example number 2 here for today, something like this, and you might remember these. What is 60% of, and let's just think of a number. I don't know, let's go with 42. Okay, what is 60% of 42? We have to figure this one out, right? So there's lots of ways to do this problem, but basically what we're going to need is multiplication, right? So what we're going to do is we're going to multiply, right? 60% times the 42 to get an answer, right? When we're trying to find a percent of a number. So we'll take 42 times 60%, but we can't multiply by 60. Okay, that's not the correct form. 42 times 60 is a very large number. Okay, and what we know is, well, 60% of 42 is got to be less than 42, right? 100% of 42 is just that, it's 42. But 60% is a little bit more than half of 42, right? So if I said, what is 50% of 42? Well, you would just find half of it, right? So 21. But we want 60%. So we know it's a little bit more than 21, but we don't have an exact number. So how do you do that, right? And the truth is, right, we just need to multiply these two, but we can't multiply with the 60. We have to multiply by the decimal version, or the fraction version would be fine as well. But most of us would prefer a decimal. So that's all we're going to do. It's just multiply the decimal times 42. So what you end up with is 0.6, because again, we've got 2 spaces of movement, right, to change it into a decimal. So that's 0.6. And then we're going to multiply that times 42. Okay, so 0.6 times 42. And that's all we're going to have to do here. Now, what is that answer? That should be something like 25.2, I believe. Yes. All right. So, that's how we work with percentages. We have to have the decimal equivalent. We cannot use the percent as it is. Okay. So we can go ahead and start today's lesson then, now that we understand that we're going to be working with decimals, but as percentages. Okay. So things get switched back and forth very quickly. So today we're going to introduce simple interest. And simple interest is very easily defined as just money earned or cost of money based on the amount and a certain time frame. Okay. So, and you'll understand it better once we do an example. Okay. But it has a formula to it. Okay. So the formula is just this. It is I, which is the interest earned or cost of interest, equals PRT. Okay. And that's the formula. I equals PRT. So we'll quickly define those 4 letters. I is the interest earned / cost, just depending on the situation. We'll get into that. But interest earned or cost, and today we're going to focus on earned interest. Okay. P is what's known as the principal amount. I think it's principal. It might be principal LE for what I think might be. I think it is. I think it's LE. Let's see. I don't want to steer you wrong right from the get-go. One is a principal like the principal of your school, and the other one is a principal like your that we are talking about here. So we want to get them right. Let's see. Okay, I had it right. All right. Okay. Again, I just wanted to make sure we had it right. So yeah, central, that is your principal investment or your initial amount. Okay, so your initial amount, and then we have R, which is your rate. That's going to be your percentage as a decimal. Okay, so in the problem, they're going to tell you the percentage probably. And then, of course, they're going to want you to use it as a decimal. Okay, and then the last one is T. T is the time frame. Okay, so we're looking for a certain amount of time that money is invested. Okay, so we have just a couple of examples, and you'll see that this is fairly simple because it's just a formula that we're going to put numbers into. So here we go, right? We have $600 deposited for 30 years at we'll say a simple interest of 2%. Okay. And so this is how it works, right? This is how the simple version of how the banking industry works. Okay. Everybody likes to deposit their money into a bank. That way you have the access to it through different features like debit cards and checks. And it's somewhere where you can go and withdraw cash if you need to. But you're depositing that money into the bank. And so the bank's not just holding that money for you. It doesn't just have a stockpile of money that it holds on to. Well, it has to make money itself because, right, that's how they pay their employees, from their profits. Well, how do they make profits? Well, banks make profits based on you, the consumer, people depositing money into the bank. They leave it in the bank, and the bank uses your money to make investments in other companies, to loan out to other people, and then they charge interest in different ways. Well, the bank uses your money. So while it's deposited in the bank, while your money is in the bank and just sitting there, and you're allowing the bank the use of it, well, they pay you interest. They basically pay you a little bit for your money. And that's how you earn money just by letting money sit idle in a bank. It's much more complex than that, and you get into that more and more as you move into economics and things in high school and college. But that's the basic of it, right? You give them your money. They promise they'll give it back whenever you want it. But while you're letting it sit there, they're actually using it behind the scenes to make purchases and invest in companies and loan out to make their money. And so it's kind of a fun topic to get really researched into to find out how money really works. But this is how you're going to earn money, right? You're going to earn it simply by having it deposited. Okay. And so we use the formula to figure out, well, how much money would you make? Okay. If I just left that 600, I put it in there today and didn't touch it for 30 years, and they said, hey, we'll give you 2%. Basically 2% per year is what we'll pay you to use that money. And so with simple interest, it's all you do is put it into the formula, okay, according to what information is given. Okay, so our formula is I equals PRT. Okay, and what do we know? Well, the I is going to be the interest earned. Obviously, that's what we're trying to find out. The P is our principal investment. What did we originally put in? Okay, and that's going to be the $600 investment here. Okay, so filling in the formula, right? That is 600 times, okay, the rate. Okay, and again, the rate is your percentage, but it has to be as a decimal. So we need to change that 2% into a decimal. All right. So we've got 1, 2, right? So it would be 0.02. And I like to write the 0 out front of the decimal because it helps to highlight the fact that we have a decimal there. If you just put 0.02 with no 0, sometimes that decimal kind of disappears. And then the time, right? So that's going to be your 30 years. So this is really just a multiplication problem, and we have calculators to do this multiplication for us. Okay, so we have 2% times 30 times 600. Okay, in any event. So the interest earned is going to be $360. Okay, that's the answer to that problem. So if we earn $360 on our initial investment after 30 years, okay, so we put $600 in now, we leave it alone, we don't touch it, we just let it do its thing for 30 years. When we go back in 30 years to the bank and say, I'm ready to withdraw this money that I gave you 30 years ago, they're going to say, well, thank you for having it in there. And they're going to say, here's an additional 360. Okay. So your final total is 360 plus your initial 600. So you made $960. Not necessarily the whole amount though, right? You gave him the 6 to begin with, but you did make this. So as a total, what you would end up with in that account, if nothing changed, right, for 30 years, you got $600 in there, in 30 years, you come back, the balance on that account is going to be $960. Okay. And that is simple interest. That's how it works. Okay. You simply have a certain amount you're earning every year. Okay. So if we were to do this the long way, if we were to think about this the long way, you would earn 2% every year on that $600 investment. Well, the first year, so what is 2% of 600? Well, it's 6. So year one, right? First year, you'd have $6 in that account. Okay. Year two, you're going to get another $6 on that account. Year three, you're going to get another $6 because it's 2% every year. So 2% of 600 is $6. So every year you're getting $6 for leaving it in there. Well, 6, is it 6? Well, no, 2%. So 10, yeah, 2% would actually be 12. Sorry. 1% would be 6. So you get $12 every year you leave it in there. So after 30 years, you end up with that 360 because they're giving you $12 a year. Okay. And that's how it happens, right? Every year they just give you a flat amount based on the amount you deposited. You get it in the long run. Okay. So I'm going to give you a little example here to work yourself to see, to answer 2 questions. Okay. The first question is, how much interest earned? Okay, that's the first question. And what is your total at the end? Okay, what is your total at the end? So let's just think of some other amounts that we could look at. Let's say we go with a initial investment of $1,500 for 10 years at 3.5%. Okay, that's our setup, right? 1,500 for 10 years at 3.5%. Right, go ahead and pause the video for a second. See if you can work this one out on your own. and then I will go through and talk about this problem. Okay, so what we have is going to be a very simple interest problem, right? We're just looking at I equals PRT, filling in that formula. Okay, so that's going to be the initial principal investment of 1,500. Now, the curious thing here is where I wanted to point this out, right? The rate is 3.5%. Well, what does that mean, right? 3.5%, that's 3.5 per 100. And again, I need to change this to a decimal. I realize there is already a decimal in there, but right, I need to still change it. This is a percentage, 3.5%. It has to be in its decimal form in order to move forward. So I still move it 2 spaces. Okay, so that is actually 0.035. Okay, and then times our 10. Okay, so I have interest of $525. Okay, I've earned $525 for leaving that $1,500 investment in the bank for 10 years and not touching it. So that would be my interest earned, right? I get $525. Now, to get a total, you simply add that to what you initially had in the account. So the account balance is going to be $2,025. Okay, that's going to be our total at the end. All right. One more example that I want to work through for you is going to be, how do we work backwards? Okay. So there are going to be times, okay, that they're going to give you, okay, a question. Okay, so example 3, and it's going to say if something like $600 was invested and 4 years later, 672 was withdrawn, what was the rate? Okay, so what were they paying them for that 4-year time? How much were they? What was the percentage gain in that 4-year time? Okay, so we don't want to know, 600 is what percentage of 672. We don't want to know what 72 is of 600, anything like that, right? You simply go back to the formula. Okay, so interest equals PRT. Okay, and knowing what each piece was it helps us get to what we need to know. Okay, so easy one to notify is time, right? Well, how long was it? Well, it was 4 years. Okay, and then the other one is our principal investment. Well, we put in 600. Okay, so we have 600 times the rate, which we don't know, times 4, something, right? It's going to get us there. Now, we also have this guy. Okay, remember that is the interest we earned. Okay, so if I'm looking at withdrawing this amount after putting in this amount 4 years ago, how much did I earn? And the easy way to figure that out, right, is subtract those two, find out what the difference in those. Very easy, right? We have 72. Okay, so there's 72. Now, again, we're slowly getting to what our answer is going to be. But this is going back to unit, I think 2, when we did equations. Okay, we are trying to solve for this variable right here. We're trying to solve for R. Okay, now initially we can clean this up a little bit and go ahead and multiply 600 times 4. Okay, so this is 72 equals 2,400 R. Okay, so 2,400 times whatever the rate was. Okay, so how do I figure that out? All right, well, think about a little side note. If I had 20, let's say 28 equals 7x, right? Most of us already know the answer to that. It's 4. Okay, but how would I solve that if I didn't? Well, I do the opposite, right? I divide by 7, and that gets rid of it here, leaving me with just the x, and then 28 divided by 7 is 4. Okay, it's just a one-step equation. We do the opposite. Well, this is multiplication. So what do we need to do? We need to divide 2,400 on both sides. Okay. Now, you might say, I know something's going to be wrong here because look, 72 doesn't divide by 2,400, and it shouldn't, right? It should produce, you're going to see it, okay, a decimal. Okay, that's our decimal answer there. And they want a rate. Well, how do you change a decimal into a percentage, right? How do we answer the rate question? And the answer is we just move that decimal to the right. Okay, so 3% is my answer. Okay, so that's how we're going to work backwards in these problems. Now, I realize this is a lot in just a little bit of time. So if you need to break this video up and watch it twice, just to get everything in a little chunks, that's fine. Watch it twice all in one sitting. That's okay too. If you have questions, comments, or concerns, please get back with me. I'll be glad to try and answer those for you. But we've got to get through the unit. We got our CUA. Our next CUA is going to be coming to us on the 11th of March. So lot to get through in a little bit of time. Thanks, guys.